is a statement, I just write it down over here. Whenever the electrons of a covalent bond, okay, covalent bond is shared unequally between two atoms of different electronegativity, comma, it creates an electrical dipole in a bond. Okay, so that means unequal sharing is a major underlying cause of bonds polarity. Suppose you have X and Y, these two atoms. Okay, if they are equal, they could, the sharing of electron, if it is equal, you can say the cloud is equally dense. But if it is X, the Y is more electronegative than X, then you find that the electron cloud towards Y, it is more dense. Okay, and that's the reason you get delta minus and the delta plus in a bond. And who introduced the delta sign? It is introduced by Sir Christopher Ingold in 1926. Okay, and it denotes the bond's polarity. Now over here, if the bond is completely dissociate, okay, then those bonds cannot be called as covalent bond. Okay, if it is completely dissociate, like for example sodium chloride, okay, it is written as sodium plus and the Cl minus. So this is an ionic character. So you can say that completely, if it is dissociate, then it can create the ionic bonds. Okay, now the difference in electronegativity between the two atoms of a bond determines the bond's polarity. Okay, so this two difference is very important. So if the difference is less than 0.05, less than 0.5, it is known as non-polar, and if it is less 0.5 to 2, then it is polar. Okay, then if it is more than 2, then it can be called as ionic. So now I have already given you the different electronegative value. So suppose I will tell you that OH, okay, and FH, which bond is more polar in nature. So in that case, how to say that? You can see that the difference between O and H, it is 3.44, the electronegativity, minus 2.20. This gives you 1.24. And over here, fluorine is 3.98, and again 2.20, which gives you 1.78. So definitely I can say FH bond is more polar. Okay, more polar in nature. So that's how we come to know about the polarity. The moment it is having some polarity, okay, the polar bond exhibit a dipole moment, which is E into D. Okay, for example, you have water molecule. Now water molecule, this hydrogen electron is pulled by the oxygen because higher electronegativity, and both the hydrogen is having delta plus, and this is their center of positive charge, and this is the center of negative, and that is the distance. So this distance, if it is not is equal to 0, then dipole moment also not is equal to 0, we can say the molecule is polar in nature. But there are some molecules like carbon tetrachloride. Okay, chlorine is attracting in all the direction, so the distance becomes 0. So mu also 0. So the compound become non-polar. Similarly with BF3, why BF3 is non-polar? Because it is trigonal planar. So all the fluorine, is attracting the electron towards itself, and as a result that the positive and the negative charge, the center of positive charge and the center of negative charge coincide, and the distance becomes 0. Okay, so that's the reason the polarity, can measure by the dipole moment over here. Now the next concept is, I would like to go ahead with the bonds polarity, that is formal charge. Okay, now suppose you have over here carbon dioxide, and I have to calculate the formal charge. So formal charge actually, I can read out. Formal charge is the charge